Kia ora class, I'm going to go through the first example for our simulations booklet. So this is an example on chicken breeding. So our situation is that Kaimoa Farm in Auckland breeds black chickens. The farm started in 2015 and they calculated that 40% of the chickens in that year were black. So we need to use the information above to design and run a simulation that can be used to investigate the probability of getting 2 or more black chickens when 5 chickens are randomly selected. And this describes what you need to do. So we need to describe our simulation method with enough detail for another person to replicate it, record our outcomes clearly enough for someone reading them to be able to confirm or challenge your conclusions, use our results to write a conclusion about the probability of getting 2 or more black chickens when 5 chickens are randomly selected, and also include the estimates of the average number of chickens checked, the chances of having 2 or more black chickens, and any other findings from our simulation, and then state any assumptions and suggest possible improvements and or other variables to consider when investigating the situation. So basically all of your tasks are going to look like that. You're going to have some sort of situation, you're going to have a task that describes what you need to do. Most of this stays the same. The part that changes is writing the conclusion, where it may ask you to do 1 or 2 things, and that will impact on how you're going to run your investigation. Now, our investigation uses the same format the whole time, where you have to talk about the tool you're going to use to run the simulation, the trial, so what a trial looks like. You're going to have a recording, you're going to write a conclusion, and you're going to have a discussion. Now, you don't need to do all of this to pass, but you need to do the tool, trial, record, and conclusion part. The discussion is if you want to push your thinking to a higher level and really investigate what this whole thing is about, and see if there's any issues with it. So we'll start with tool. We're going to be using Google Sheets to do this simulation, but you can also use a calculator. If you want to use a calculator, you'll need to refer to the paper booklet and ask your teacher how to do that, but I'm going to show you how to do it on Google Sheets only. So we say a very similar thing to what we did if we were doing it with a calculator. We decide how many random numbers we want. So since the probabilities are shown to 1 decimal place, I want 10 random numbers. This is from here, where we're looking at 40% of the chickens. So that is the same as 0.4. So that's 1 decimal place. So I'll just add that. So that's 1 decimal place. So that means that we're working with tenths, because this place after the decimal point is that's your tenths column. So you only need 10 random numbers. I'll use Google Sheets with the formula equals random between 1 and 10. So we want 10 random numbers because we know that 40% of our chickens are black, which is 0.4, and that means that we're only going to need 10 random numbers to represent the chickens that are black and not black, because 40% of those, 0.4, are going to be black, and then the other 6 numbers are going to be not black. So we need 10 random numbers, and this is the formula that you use when you're looking at random numbers between 1 and 10. You write 1 and 10. So we'll only generate random numbers between those 2 numbers that you've written in there. Every other part of the formula stays the same for Google Sheets, except for changing which numbers you want to go between to represent your black and not black chickens. This will produce random numbers from 1 to 10, and the probability of getting each of the numbers from 1 to 10 is 10%. And this next part explains it a little bit more. So the probability of getting a black chicken is 0.4, which is 40%, which is 4 tenths. So this is all different ways of representing the same probability. So I will assign 4 of the 10 numbers to that outcome. So you have to choose 4 numbers to represent getting a black chicken, because if you generate a random number, this will be a number from 1 to 10. You want to know what that number means. So I'm going to say that the numbers 1 to 4 mean that you've gotten a black chicken based on the probability that they found from 2015. The probability of not getting a black chicken is 0.6, which is 60%, which is 6/10. So that's 6 out of 10. So I will assign 6 of the 10 numbers to that outcome. So because I've already used the numbers 1 to 4, I have the numbers 5 to 10 left over to represent not getting a black chicken. I can't use the same numbers again because I've already assigned 1, 2, 3, and 4 to be a black chicken. And so if you generate a random number, it can only mean one thing for this trial. So I've assigned the numbers 1 to 4 to getting a black chicken, and now I'm going to assign the numbers 5 to 10 to represent not getting a black chicken, which is your other 60%. So that's the tool part done for this. The next part is saying what a trial is going to be. So to run a simulation, you're going to see what it would look like if you theorized how many black chickens you would pull out. And that's the idea of using a probability, assigning random numbers to a meaning based on that probability, and then running a simulation to see what those numbers turn out. So we've got to say what each trial in the simulation is going to look like, and then we're going to say how many trials we're going to do. So one trial consists of generating 5 random numbers representing the colour of the chicken, black or not black. And the reason that we chose 5 random numbers is because it said investigate the probability of getting 2 or more black chickens when 5 chickens are randomly selected. So we know that we're only going to pick 5 chickens. And it's either going to be a black or not a black chicken. So we want to investigate if you can find 2 of the 5 chickens black. So that means that having 2 or more black chickens means that it was a success. So if I get the number 10, that was assigned to not getting a black chicken, so that's N for not black. Number 4 was assigned to getting a black chicken, so that's a B for black. 7 was assigned to not getting a black chicken, so that's N. 1 was assigned to getting a black chicken, so that's B. 2 was assigned to getting a black chicken, so that's B as well. Now there were 3 numbers that represented getting a black chicken in this set of numbers, so that means that this is 2 or more black chickens, and so it was a success. So that's my example of a successful trial. And I've got to say what an unsuccessful trial is. If a successful trial was getting 2 or more black chickens, then an unsuccessful trial is when you have less than 2 black chickens. So I got the numbers 8, 9, 3, 5, and 8 again. 8 and 9 and 5 all represent not getting a black chicken. So they were given N. Number 3 was assigned to getting a black chicken, so that is B for black. Because there weren't 2 black chickens out of these 5 imaginary chickens that I'm doing a trial for, that means that it's an unsuccessful trial because we're not achieving what we are looking for. I will finish when there are 5 random numbers because the question stated only 5 chickens were allowed, and I'll do 30 trials. You can do more than that, but 30, we use it because it's enough trials to give us a good idea of the probability and the average number of chickens checked. So that's the number that I'm going to use for my examples. I'll look at recording in the next video. Thanks for watching.